We're talking about probability today, and sometimes probability seems a little bit removed from statistics because you're like, this has nothing to do with what we just learned, but it really does because the probability tells us what is the chance that if we take data that we're going to get a certain outcome. And that's really, statistics is like the act of taking the data and analyzing the data, and the probability is really figuring out if I take data in the future, what can I expect that data to look like? Okay, so there's a couple terms we're going to talk about. First, sample space. Sample space is the range of all values that an event can take on. So if you're rolling a dice, the sample space would be all the possible outcomes. What are the possible outcomes of rolling a die? You can roll a 1, a 2, a 3, a 4, a 5, or a 6, right? We would call rolling the die the event. And then the outcomes of the event are rolling a 1, 2, 3, 4, 5, or 6. And that would be what we would call our sample space. Now, the probability of getting something would be all of our favorable outcomes divided by the total number of outcomes. In other words, if I say, what's the probability of rolling a 6? Well, a favorable outcome would be a 6, right? Then that's the outcome that I want. And how many total outcomes do I have in my sample space? Well, I have 6 of them. So one of the outcomes is what I want, and there are 6 total outcomes. So the probability of rolling a 6 is 1 in 6, and that's how we calculate probability. Hopefully that's somewhat of a review. But I know it's been a long time because we never ever get to statistics and probability most years. So this may be like way back here in like 5th grade. Okay, so let's look at some examples. If I have a spinner and I want to find the sample space of that spinner, it has 4 equal sectors that are colored red, yellow, green, and blue. I just read those in the wrong order for some reason. Anyway, what's the sample space? What are all of the possible outcomes I could get? Well, I could get yellow, I could get blue, I could get green, or I could get red. So my sample space is yellow, blue, green, or red. And you could abbreviate this. Oftentimes people would abbreviate this. So we draw the little curly brackets and we could say, yellow, blue, green, and red. And then we could ask the question, what is the probability of getting yellow? So this P with a parentheses around it means what is the probability of getting whatever's inside that parentheses? What is the probability of getting a blue? But I could just write it out. What is the probability of getting blue? So you don't have to abbreviate. Okay, you roll an 8-sided dice. What's our sample space? Well, we have 8 different options, right? So the sample space is every single option that we could possibly get. So 1, 2, 3, 4, 5, 6, 7, 8. That's our sample space. And then we could ask, what's the probability of getting an 8? Well, there's one favorable outcome, which is 8. And how many total outcomes are there? There are 8 total outcomes. So the probability of getting an 8 is 1 out of 8. What is the probability of getting an even number? What's the probability of getting an even number? Well, how many favorable outcomes are there? A favorable outcome in this case would be an even number. So it'd be 2, 4, 6, or 8. So there are 4 favorable outcomes. And how many total outcomes are there? Well, there's 8. So the probability of getting an even number is 1/2. And you probably could have guessed that. I know that's like super simple, but it gets complicated quickly with probability. So realizing that we can really like sink our teeth into that is important. Okay, so a glass jar contains 1 red, 3 green, 2 blue, and 4 yellow marbles. If a single marble is chosen at random from the jar, what's the probability of each outcome? Now, honestly, in like higher level stats, we wouldn't often list each of the outcomes more than once in our sample space. But in our application, I want you to list the sample space like that. So if you have 1 red, 3 greens, go ahead and list all 3 greens. If you have 2 blues, list both blues and the yellows, because then it helps you see how many different options are in the sample space. So it helps you really understand probabilities better. So how many options do we have? Well, if we counted up all of the marbles we had, we actually have 10 marbles. So what's the probability of getting a red? So to find the probability, we say, what's the favorable outcome? Well, that's red. And so there's 1 favorable outcome out of how many total outcomes? Well, there's 10 total outcomes. And remember that this notation right here, P with the parentheses, means what is the probability of, and then whatever is inside the parentheses. So if you wrote red or purple or whatever, what is the probability of purple? Well, the probability of purple is 0 because there's not a purple one in there. All right. What's the probability of drawing a green? Well, we have 3 favorable outcomes, right? 3 options to draw green. And then there are 10 total options, total outcomes. So our probability is 3 out of 10. What's the probability of getting a blue? Well, that would be, there's 2 blues, so that's 2 out of 10. And the probability of yellow would be 4 out of 10. And in this case, I'm not going to have you simplify any of them. It's totally fine, totally fine just to leave this as 2 out of 10 and 4 out of 10. If you wrote this as 1 out of 5, you would not get marked wrong. And if you wrote this as 2 out of 5, that would be as fine as well. But it's fine if you just leave them not simplified because it helps you compare them a little bit better.